So we're going to work on the idea of geometry concepts, chapter 5. We notice in section 5.1 we start with perimeter. So in the end we notice that a lot of shapes we're just looking at. For a triangle, we know we've got the perimeter is a plus b plus c. So if we have a closed geometric shape, with sides that are straight lines, we know the perimeter is just the sum of the side lengths. So if we have a rectangle, with length L and width W has perimeter P equals 2L plus 2W, because we can also just think of that as being L plus W plus L plus W. Either way, we get 2L plus 2W. So if we looked at something that was a rectangle that was 3 by 4, we notice the perimeter is 2 times 3 plus 2 times 4. We get 6 plus 8 gives us 14. And then if we don't have a unit specified, we'll sometimes just say units. If we had said a picture frame is a rectangle 14 centimeters wide by 40 centimeters long, the perimeter is 2 times 14 centimeters plus 2 times 40 centimeters. And so we get 28 centimeters plus 80 centimeters is 108 centimeters. So we like to have units if they're available. So a square with side length S has perimeter for S because all 4 sides are the same, so that makes that easy. Then we have trapezoids, are a little trickier. In general, with a trapezoid, we don't really have anything nice. We're just going to notice that we could call those sides A, B, C, D, and so that's going to be pretty much the equivalent of any quadrilateral. Rhombus is a little bit like a square, we notice that we have all four sides are the same. And so the perimeter there, again, is 4s. Parallelograms are a little bit like rectangles. We notice that we don't exactly have a length and width in this case, but we notice that we have opposite sides are equal length. And so we notice that the formula for a perimeter parallelogram is going to be similar to what we get for a rectangle, just only difference is that we don't know the length and width. We just have these two different side lengths. Circles are a little bit different. Circle, remember, is the set of points equidistant from a center. So we notice that given a center, we notice that every point on that circle is the same distance from that center point. And we know that the circumference of a circle, so actually let's start with the radius of a circle, is the distance from the center to any point on the circle. So we notice that if we draw a line from the center to the circle, we know that's going to be radius, the distance is r. And if we drew another line from the center to another point on the circle, that distance is still r. And if we did it again, we'd still get r. So any point on the circle is r units from the center. And so once we've got that, we know the circumference of the circle. So the perimeter of the circle is called the circumference. And we know that c, that circumference c, is equal to 2 times pi times the radius. And in fact, pi is actually defined, that number pi, which we know is approximately 3.14159, is an irrational number that goes on forever, and it's actually defined as being the ratio of the circumference to twice the radius, or circumference divided by diameter. We know that the diameter of a circle is defined as the distance of any line from one point on the circle to another that passes through the center. And so we notice that the diameter has to be 2 times the radius. Diameter is always going to be 2 times the radius. And the flip side of that is the radius is equal to the diameter divided by 2. And so we notice that we could also say circumference equals pi times the diameter. Or pi times d. Once in a while we'll see things like half circles or quarter circles. We notice that the perimeter of a half circle, also sometimes called a semicircle, we notice we have to be careful because now we have to think about that radius. We notice we're going to get 1/2 of 2 times pi times the radius. But then we're going to add 2r for that bottom part. So we're going around, go around the half circle, but then we have to go back around along the radius, well, along that bottom part. And so similarly, if we had a quarter circle, we would get perimeter of 1/4 of 2 pi times the radius plus 2r again, because we notice we would wind up getting 1/4 of that distance around the circle, but we still have those two sides, two straight lines that are both of length r. Where life gets a little more interesting is composite figures. Are figures made up of different shapes. And in general, we have to just use logic to get the perimeter. We notice that if we had a triangle on top of a square, and we knew that, so say it's an equilateral triangle on top of a square. So example, equilateral triangle with side length 5. On top of a square. We get a perimeter of, we notice that the original triangle has 5s. Whoops. The original triangle has 5s, and so for a square to be underneath it, we need to get 5, 5, and then those 3 sides of the square have to be 5s, and so we notice the perimeter is going to be being 5 times 5, and so we get 25. If, on the other hand, we had a triangle that we didn't know, if we had, for instance, if we knew that it was 3 units by 4 units by 5 units, then we notice that our equilateral, then our square would still have those 5s, but now we get our perimeter would be 3 plus 4 plus 3 times 5, because we notice the square doesn't have a top, it just has that triangle on top of it. And so we end up getting 7 plus 15 is 22. And so we have to be careful about that. If we looked at, say, a rectangle with a center taken out of it, so if we want to know the perimeter of the shaded region, let's say it's 7 by 12, and then we'll say that inside rectangle is 4 by 8. We notice that the perimeter of that outside, how do we think about that? Let's actually change that. Ooh, let's do it this way. That's better. So we'll make it a U shape. And we'll say that the outside height is 7, the inside is 4. We know that the outside width is 12, the inside width is 8. And so we have to think quite a bit about what the dimensions of this are going to be. We notice that we're missing the widths of those arms up at the top. But we notice that inside width of 8 and that outside width of 12, we notice that 12 minus 8 is 4, and that remaining 4 units has to get split up between the other two, and so we know the A's have to be 2's. And so now, to get the perimeter, we notice that we're looking at 7 plus 12 plus 7. Then we have to add on the A plus the 4 plus the 8 plus the 4 plus the 2, and that gets us all the way back around. We notice that we had 1, 2, 3, 4, 5, 6, 7, 8 sides, and we notice that we're adding up 1, 2, 3, 4, 5, 6, 7, 8 numbers, and we get 26, 28, 32, 46. And that's about as complicated as one of those is going to get. We're not going to have anything too horrible. We actually noticed that if we wanted to write something really strange, we noticed that if we started with a rectangle, just make it 4 by 8, we noticed that if we make tiny little slices in it, we notice that the more small rectangles we cut out, the larger the perimeter gets. We're not going to have any that are quite this messy, but if we imagine that all of these were 1 unit, if we imagined all of those were 1 unit deep and 1 unit across, we notice that it doesn't do anything to that basic 8 units across, 4 units up and down. We wind up getting the perimeter is going to be the same 2 times 4 plus the same 2 times 8, plus all those little 1 units diversions. So we go 1 down, 1 up, 1 down, 1 up. So that we do that 2 times, 3 times, 4 times, 5 times, 6 times, 7 times. So we add 7 times 2. And so we get the same 8 plus 16 we would get for the rectangle, plus 14 gives us 38. And as those little side trips, we can make the perimeter as long as we want. One of the classic composite shapes we'll see is things like rectangles with circles on top, or triangles with circles. And so we notice that if we were told that the radius of the circle, we'll keep the same radius for both. Let's say R is 4 in both cases. Then we'll say this is a rectangle that is 6 by 6 units tall. and we'll say this has a triangle that is 6 units by 6 units, we notice that for the square rectangle with the circle on top, we know what the width is. We know the width is going to be 8 because it has to match the diameter of the circle. So the perimeter is going to be 8 plus 6 plus 6 plus that circumference of the half circle. We're going to end up getting 1/2 times 2 times pi times 4. And so we end up getting 20 plus 4 pi. And so you'll notice that when we're dealing with circles, we'll often just leave it in terms of pi. If we want an approximation, we could say that's approximately 20 plus 4 times 3.14, and that's going to be 20 plus 12.56. And so we can say that the 20 plus 4 pi is approximately 32.56. Then for the triangle, with the circle on top, we notice now we're going to wind up getting the perimeter is 6 plus 6 plus the same 1/2 2 pi times 4. And so we still get 12 plus 4 pi. Well, so we get 12 plus the same 4 pi we had before because the circle, half circle is the same. And so now that would be approximately 12 plus 12.56. And so this perimeter is going to be approximately 24.56. We'll get one more example. If we tried doing a rectangle with a corner cut out, this is actually kind of interesting because we notice that if we said 8, 12, and then we just said this was A, B, C, D, if all we know is the perimeter, we don't actually need to know what A, B, C, and D are. We know the perimeter is going to be 8 plus 12 plus 8, 12, plus A plus B plus C plus D, but you notice A plus C has to match up to 12. A plus C has to match up to 12, and B plus D has to match up to 8. And so we know we're going to get 8 plus 12 plus 12 plus 8 is going to give us 40 units.